Hello everyone. Hi, welcome back. So, after learning about different concepts related to this chapter, like what do you mean by quadratic equations, introduction to quadratic polynomials, roots, and so on, from this video, we'll be seeing about the solutions of quadratic equation. Okay, so basically, I'll be talking about different methods that we can use in order to solve any quadratic equation. So, methods to solve quadratic equation. So basically there are three different types of methods. First is factorization. Okay. Second method is by completing a perfect square, and third method is quadratic formula. Okay, so in this video we'll be talking about the first method, that is solving quadratic equation using factorization. Okay, so this is a basically a simpler, very simple method. Actually, you might have used this method earlier in the chapter polynomials for factorizing a quadratic polynomial. So same method, I'll explain this to you, but pay attention because this is one of the important methods. Sometimes in the question only it will be written that solve the given quadratic equation using factorization. So in that scenario you have to use this method, hence the concept should be very clear. Okay, so let me take a general quadratic equation, ax square plus bx plus c equals to 0 with a not equal to 0. In this method of factorization, I'll tell you what you have to do. Basically, you need to factorize the given quadratic polynomial into two linear factors. Equate that to 0. Okay, suppose you have some first factor, you have some second factor. Multiplication of both will give you this quadratic polynomial, and that is equal to 0. So once you get these factors, you can equate them separately to 0. This is equal to 0 or this is equal to 0, and hence you can find the roots of the given polynomial. Okay, so now the question is, how will you find the factors? That is what I will tell you now. The method is, suppose I have ax square plus bx plus c equals to 0. You have to multiply the coefficient of x square and the constant term first. Okay, multiply this and this, a and c. Okay, in some quadratic equations the coefficient of x square will be 1, so you can directly take the constant term in that case. But in general, if you have some coefficient of x square and the constant term, multiply them and find the factors of that particular value, AC. Okay, so once you find the factors of AC, you have to choose a combination. Okay, you have to choose a combination in such a way, in such a way such that the product of the factors of AC is equal to AC, and the sum of the factors of AC is equal to coefficient of x, that is B. Looks complicated? No, 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 it is not, obviously not. Okay, when I'll take an example, it will be much clear. Okay, let me tell you how. Let me take a first very basic example. Say x square plus 6x plus 5 equal to 0. The question is, you need to solve the given quadratic equation, that is you need to find the roots using the method of factorization. Okay, so as I told you, first of all you need to multiply the coefficient of x square with the constant term. Now the coefficient of x square is 1 here, so it won't make any difference. Just take the constant term 5. Write down the factors of the given constant term. The factors of 5 are 1 and 5. Okay, now I have told you that you have to choose the factors in such a way that the product of the factors is equal to this and the sum of the factors should be equal to this. Now if I'll take 1 and 5, I know that 1 into 5 is 5, which is same as this, and 1 plus 5 is equal to 6, which is the coefficient of x. Hence I can choose the factors 1 and 5. After knowing the factors, I will split this constant, this term, middle term, in terms of 1 and 5. That is x square plus 6x plus 5. I'll write it as x square plus 5x plus of 1x plus of 5. Okay. Now what I'll do? From the first two terms, I'll take out whatever common thing I can take out. From this and this, I can take out x common. So remaining is x plus 5. And from this and this, I can take out nothing. So 1 into x plus 5. Now from this term and from this term, I can see that x plus 5 is common. So I'll take it out, x plus 5. Remaining will be x plus 1, so equal to 0. So this is my factorized form of the initial given quadratic equation. Hence, my factors of x square plus 6x plus 5 will be x plus 5 and x plus 1. Now if I need to find the roots, I'll equate x plus 5 to 0 and x plus 1 to 0. So from here x is equal to minus 5 and from here x is equal to minus 1. So minus 5 and minus 1 are the roots of the given quadratic equation. Okay. This is how you use the method of factorization. Okay, let me take a couple of more examples to make this concept more clear. Okay, suppose the given quadratic equation is 9x square minus 3x minus 2 equal to 0. I need to factorize and find the roots. Question is, find the roots of the equation using method of factorization. Okay, so I hope the question is clear. Okay, see, so now I'll follow the same procedure. Take the coefficient of x square and the constant term, multiply them. So 9 into minus 2 is equal to minus 18. Okay, now see this very carefully. I will try finding the factors of 18. Okay, factors of 18 are 1, 18, 1 and 18 because 1 into 18 is 18, 2 and 9 because 2 9s are 18, 3 and 6 because 3 6 are 18. Okay, if you write the factors in this way, then it will be easier for you to identify the combination. Okay, any other possible factor? No, we collected all the factors. Now see, according to that concept that I told you, you have to choose the factors in such a way that the sum of the factors should be equal to minus 3 and the product of the factors should be equal to minus 18. Now remember that you are free to take the combination with any sign. Okay, that is upon you. You can take plus 2 minus 9 or minus 3 plus 6 plus 1 minus 18, whatever possible you can take. The only condition is the sum of those two factors should give minus 3 and the product of those two factors should give minus 18. Okay, so let me start with 3 and 6. Okay, if I'll multiply 3 and 6, I'll get 18, but I need minus 18, so I will reject this. Let me take minus 3 into 6. Minus 3 into 6 is minus 18. Satisfying? Now let me check the sum. Minus 3 plus 6 is plus 3. But what do I need? I need minus 3. Hence again I will reject this. Okay. So now what I will take? Let me reverse the sign and let me take minus 6 into 3. Minus 6 into 3 is minus 18. Satisfying. And minus 6 plus 3 is minus 3, again satisfying. So both our conditions are satisfied. So my combination will be minus 6 and 3. Okay, so I'll write the given equation as 9x square minus 3x minus 2 equal to 0. This was the given quadratic equation. I'll split this as 9x square minus of 6x plus of 3x minus of 2 equals to 0. So this becomes, from this I can take out 3x common, so remaining is 3x minus 2, and from this I cannot take out anything common, so I'll just take it out 1 into 3x minus 2 equals to 0. Okay, so finally I have 3x minus 2 into 3x plus of 1 equal to 0. Okay, so what are my factors? 3x minus 2 and 3x plus of 1. So the question was to find the zeros. So I'll equate 3x minus 2 to 0 and 3x plus 1 to 0. So this means x is equal to 2 by 3, and from here x is equal to minus 1 by 3. So these are the roots of the given quadratic equation. Okay, now some people think that they have a doubt, where there's a very genuine doubt, that why I should write minus 6 and then plus 3. Can't I write 3x and then minus 6? Okay, it is both ways, it is correct. Even if you write it 9x square plus 3x minus 6x equals to minus 2 equals to 0, still you will get the same roots. It will not change. Okay, so it doesn't matter whether you write minus 6x plus 3x or 3x minus 6x. Okay, only the conditions should be satisfied. The order, the arrangement can be anything. It won't matter. Okay, so I think this concept is clear now. I'll take one more example. Say if I have root 3 x square plus 10x plus 7 root 3 equals to 0. Okay, I need to find the roots. So what I'll do, I'll take the coefficient of x square and the constant term, multiply them. So root 3 into 7 root 3 is 7 into 3, 21. So now I'll try to find the factors of 21. Factors of 21 are 1 into 21, then 7 into 3. Okay, so these four are the factors. Now I have to take a combination in such a way that the product of the two factors is equal to 21 and the sum of both the factors should be equal to 10. I guess you can easily see what it is. It is 7 and 3, because 7 3s are 21 and 7 plus 3 is equal to 10. So I will write it that root 3 x square plus of 7x plus of 3x plus of 7 root 3 equal to 0. Now from this, let me take out x common, remaining is root 3x plus of 7, and from this I can take out root 3 common, so plus root 3, remaining is root 3x plus of 7 equal to 0. So finally I have root 3x plus 7 into x plus root 3 equal to 0. Okay, so these are the factors of the given quadratic equation. So what will be the roots? Root 3x plus 7 equals to 0 and x plus root 3 equal to 0. So from here x is equal to minus 7 by root 3, and from here x is equal to minus of root 3. I will rationalize this and write it as minus 7 root 3 by 3. Hence the roots are minus 7 root 3 by 3 and minus of root 3. So now I think it is pretty clear the method of factorization, how to use it to find the roots of the given quadratic equation. I hope you liked it. Please do subscribe our channel, share the video, tell it to your friends, spread the word so that they can also benefit it. Please like the video. Have a nice day. Thank you.